6.6. Example 3 of conservation of energy. A 2.0 kilogram projectile was shot straight up in the air, leaving the gun barrel at 30 meters per second. The projectile reached a height of 15 meters with a velocity of 22 meters per second. How much energy was dissipated as heat due to air resistance? As you can see, here we have our gun shooting the bullet straight up in the air, and using the clues demonstrated with the colors here, we were able to extract variables. Here we have the height that the bullet reached, which was 15 meters. Here we have final velocity at that 15 meters, which was 22.2 meters per second. Down here we have the mass of the bullet, which was 2.0 kilograms. And here we have the initial velocity, which was 30 meters per second. This purple here represents how much energy was dissipated as heat, which is what we're trying to find. So we've used these variables and we put them over here into our givens box just to make them easier to see. So we have mass, height, initial and final velocity, and our unknown variable. In the next part of the question, we need to find potential energy initial and potential energy final. To do that, we're using the equation energy potential initial or final equals mgh. We plugged the appropriate variables, seen color coordinated here, into these two equations, and we came out with our two energy potentials. Here's the initial and here's the final. We've done a unit check here to make sure all the units match and that they are in fact joules. For the next part of the equation, we need to use a different equation for energy kinetic, initial and final, to find both of these. So we have this equation, which is energy kinetic, initial and final, equals 1/2 mv initial squared. So we plugged again the appropriate variables into these equations and did our unit check, and we ended up with energy kinetic initial as 900 joules and energy kinetic final as 493 joules. For the final step of our question, we put all of the variables that we just found, so we have energy potential initial and final and energy kinetic initial and final, into this final equation, which is energy potential initial plus energy kinetic initial equals energy potential final plus energy kinetic final plus heat energy, which is the one that we're trying to find. So we switch around the equation so that heat energy is our primary variable, and then we just plug in everything that we have, which we found up here, check the units, and using this we were able to find out that how much energy was dissipated as heat due to air resistance, and the answer was 113 joules of energy were dissipated as heat due to air resistance.